Welcome.
老黄的经典皮。
Great job, guys. We're gonna kill it. Don't panic. Everything's gonna be fine. There is so much technology in this room right now. It's barely under control. Okay, so you guys are gonna have a great show. Welcome to the launch of the GeForce GTX 1180.
1180。这也是个小的场馆，和那时候在台北看 AMD 发布会差不多。
I have never seen anything that leaked this much. The good news is you're going to be surprised.
这个好消息可以让你
We
们
didn't
惊
do it
喜
on。purpose, but everything on the web, every spec is wrong.
所有在网上的信息都是
You're
错
going
的
to。be surprised. It's going to be a great show. This is a historic
这
moment.
个
This
消息
is
会
a
震撼到
historic
你们
moment。for computer graphics. For as long as there has been computer graphics, it has been the dream of computer scientists to generate with computers photorealistic images. When you look at this, what we consider the holy grail of computer graphics, you see some effects
上的消
that
息都是假
today
的，
are
真的假
simply impossible to create. First of all, light is coming in from the window. It's bouncing all over this room. The vast majority of this room is being illuminated indirectly. Whenever light touches a material, strikes a material, that material is rendered and simulated physically. The material is metallic or dielectric, is either smooth or rough. The roughness can come from microsurface structures that bounces light,
术语的话听
absorbs
不太
light,
懂。
diffuses light in a very different way. Maybe it's orientation dependent, maybe it's not. Some of it is glossy, some
我
of it is
听得到
matte,
自己声音。
and as a result, this entire room looks alive. As light is bouncing around this entire room, it doesn't strike every surface the same way. Some of it is occluded from light. We call it ambient occlusion. You also see that there's a desk lamp, and it's shining through the glass, and because the glass has curvature and shape, light refracts around it and accumulates in a way that we call caustics. That little bright reflection on the table is particularly attractive.
On the table.
The shadow of phasma coming from all different directions. It's called umbra and penumbra.
刷
Umbra
新
is
有机
where
把圈圈刷掉吗？
the shadow is completely occluded.
我信一下，信你们，我刷新一下。天哪，会不会被挤掉了？刷了就进不去了。
A little bit of
哎，
shadow
这个线路
behind
没有圈
that
圈。
painting. Or as light
OK，
travels through
刚
those
我没
gummy
说，
bears, bounces around inside the jello,
刚刚不是还没有吗？
reflects and refracts it back out, called subsurface scattering.
哦，没了。
All of those
哦，
little
没了
tiny
没了。
effects
好好好好，
are
行，
really,
没了
really
没了没了。
hard to do. And the good news is, in 1979, a
好
computer
消息
scientist
是
named Turner Whitted,
，1979，
now a researcher at NVIDIA,
1979年，
described an algorithm that was both
就是刚刚那
powerful
个宣
and
传
elegant.
片。1979年的时候，我们弄了一个混合的 什么鬼的光线追踪。
By starting from your eye instead of from
今
a
天的
light
主题是
source
光线
where
追踪
light
了。
is emitted, because the vast majority of the light doesn't reach your eyes, so there's no reason to trace them. He traced light backwards, inverse ray tracing, through the eye, through the pixel, through every single pixel on the screen. The ray would seek out, would be sent forward, and if it were to strike a triangle,
MD 游戏卡要等到明
decide
年，
whether it's in shadow.
今年是没有游
That
戏
shadow
卡。
ray would go towards the light sources. If there was
哎
something
呀，
else
就是
in the
说我
way,
们
if
以
it
前
strikes
做
another
了什么，
triangle,
做了什
it
么
would
哦，
determine that it was in shadow.
就是回顾，
And if it
对
doesn't,
吧？
then it would
忆
accumulate
苦
the
思
color and the
甜，
intensity of that
对
light
对对，忆苦
would
思
then
甜。
be used to shade that.
我们以前的光线追踪技术是什么样的？那现在的技术是什么样的？
Going through
应该
another
这个意思
pixel were to strike a reflective surface, it would generate shadow rays to see if it's in shadow, and it would also
AMD 显卡也有在做了，只是说今年游戏卡的话没有，就专业卡。
basically the same incident angle relative to the normal of that surface where it's
甜品卡啊，甜品卡至少11月。
strikes another triangle, and if it were to strike another triangle, it would create shadow rays. It would determine whether that particular surface was in shadow or reflection rays and such. And if it was to hit into a surface that is translucent, then it would generate refraction rays based upon Snell's law. And that this basic algorithm, would recursively run.
哎呀，我发音很水的，
he would generate this
发音很水的。
beautiful image. In 1979, he generated this image.
没事，我这边有那个，我这边有在录，我看一下。
$1 million VAX computer. Basically, he was generating 60 pixels.
我这边有在录，所以说你们看不下去的，明天来看，我明天发一 B 站里，也是可以的。
From that time, for us to be able to realize this incredibly beautiful picture that I just showed you a second ago.
11月份差不多才有。
If you look at our technology curve, has been nothing short of extraordinary. And, ladies and gentlemen, you have so much to do with it.
好。
Because of the extraordinary demand
明天有
of
字幕
video
吗？
games and the
我看能不
scale
能
and
找到
the
我朋友
size
帮我翻译
and
一
the
下。
vastness of this entire industry, it has propelled one of the most fast advancing technology in the history of computer science. If you look at this curve, Moore's law has been the foundational thought, the foundational idea of computer science for 35 years.
GPU
And
的
yet during this entire time
Revolution
since our
GPU
beginning, we have been moving at 10 times Moore's law.
我觉得移动端应该不会拉开差距，拉开差距就是历史倒退，
10 times every 5 years. 10 times every 5 years, or 100 times every 10 years. Our GPU technology was advancing at 1,000 times every 10 years. 1,000 times every 10 years. And so the question is, and by the way, these are some of my favorite GPUs.
真的吗？
Look at GeForce 256.
那你私聊我一下，你私聊我。
World's first
你有没有加
How many of you had GeForce 256?
你私聊我。
Incredible, thank you.
翻译，然后我们发到 B 站去。
Look how cute GeForce 256 is. At the time, so you know, at the time, it was the single largest chip ever built. It was bigger than a CPU, and people were shocked that we built something that big, and they were even more shocked that we could sell something that big. But anyways, GeForce 256. GeForce 3 was the world's first programmable shader. GeForce GTX 8800 was the first CUDA GPU, the most important GPU we had built up to that time. And then, of course, the most powerful GPU in the world today, the GTX 1080. Well, if you were to plot out this trend and you were to think about how many rays it would take, you had billions of rays we had to send into that room, even though we're not simulating most of the rays, only the ones that are coming into our eyes. We're sending in billions of rays into that room. We've got diffuse rays that we have to do. We have reflection rays, refraction rays, and it's bouncing all over the world, all over the scene. And you have hundreds of polygons, hundreds of millions of polygons. The amount of computation necessary is easily in the several petaflops. Well, several petaflops, we're already at the teraflops today. So it would take approximately 10 more years. Approximately 10 more years at our current rate of progress to go from teraflops to petaflops.
180太8900 180的话6800左右。
We didn't want to wait that long. And as you know, architecture is the single greatest lever in computer graphics. It is the single greatest lever of GPUs. So what are the interesting new ideas we could create that allows us to achieve effectively 1,000 times more performance 10 years earlier? And so we invented the NVIDIA RTX. The NVIDIA RTX is a platform consisting of architecture and software and SDKs and libraries that allows us to combine different types of rendering technology into one unified and cohesive platform. Of course, it should always take advantage of rasterization. Rasterization is so incredibly powerful and so incredibly efficient. But we also need to include ray tracing. However, just ray tracing at brute force level simply won't get us there. It simply won't get us there. In fact, I'll show you something later that's just really amazing. It simply won't get us there unless we use this technology we discovered about 6-7 years ago called deep learning or artificial intelligence.
听得懂的朋友可以在右下角
along with ray tracing
打出来。
that allows us to achieve the levels that we otherwise
然
can't
后
imagine.
因为我这个录屏是包括这个弹幕也会录进去的，所以说你们明天可以在弹幕里上电视。
which is the way that we do things today. We start with the 3D world, and we take the 3D world information, the vertices, the triangles, and we project 3D world vertices into a 2D world pixel plane, into our screen space. That projection leaves the silhouette of a triangle, and we have to decide and test which one of the pixels are within that triangle. One of the most beautiful things about rasterization is that you could parallelize an enormous amount of calculation, and nothing is more beautiful than being able to do things in parallel. That's one of the reasons why the GPU is so incredibly powerful at parallel processing. It started with the idea of doing things in parallel. It also has the ability to do things incredibly high resolution, because high resolution is just more things in parallel. And so rasterization was incredibly powerful. One of its limitations, however, is that every single time you want to light the world, you have to project light from that light. And if you want 2 or 3 lights, that's fine. If you have an area light, that's effectively infinite number of lights. And if everything in the room were to reflect light, and everything in the room became a lighting surface, otherwise known as global illumination, in the world of global illumination, all of a sudden the number of lights that you would have to cast inside that scene is just insane, and therefore undoable. Well, this is where ray tracing is particularly effective, because ray tracing using Turner-Whitted's approach simply traces the number of pixels that comes into your eyes, the number of rays that ultimately reach your eyes. The vast majority of the rays inside this room, the vast majority of rays in the world simply never are reaching our eyes. And so we immediately reject them. We immediately don't have to do them. And we start from ray tracing our eyes. Ray tracing, whereas rasterization is taking 3D world data, projecting it in 2D, ray tracing is sending out a ray of light, intersecting the pixel at the screen space, and enters into the world looking for a triangle that it would intersect. The 2 basic approaches both has its strengths and weaknesses. In the case of ray tracing, in order to ray trace this entire room, the number of rays, the trillions of rays, the hundreds of millions of polygons, the amount of testing that you have to do just to figure out which ray intersected which polygon is just extraordinary.
Okay, 这样你们就可以上电视。
Well, we put this platform together, and we worked with Microsoft to create the DirectX ray tracing, otherwise known as DXR, Microsoft DXR. And then we worked with Epic to integrate RTX DXR into the Unreal Engine, the UE4 engine. And we found somebody with extraordinary art assets, Industrial Light and Magic, and together we created the world's first real-time ray tracing demonstration. It had never been done before. And we announced it this year at GDC, and I think it's worthwhile to take a look at it, and I want to show you something special about it in just a second. Okay, so this is our demonstration.
星球大战。要看宣传片吗？果然是。
What's the story with all the elevators lately? I heard Kylo Ren destroyed the one over in D sector.
那个 Y 叉叉叉那个是字幕君，对。 其实如果有同学 听得懂的话就是能做到在线发言的话，可以连个麦，我们可以连个麦，然后你那个我们就可以那啥。就可以，你们就可以在线语音直播了，是不是？
And so what you saw was physically based materials. It was sitting in an elevator shaft where there were area lights, and those area lights were moving as the elevator was moving. And therefore, as the area lights would illuminate the surfaces, and the shadows would be soft. The shadows would be soft. Using area lights and incredibly difficult to render shadows. And notice the inner reflection. There's reflection of Phasma. There's inner reflection of Phasma on her gun, and there's reflection of her gun on her chest. And if you look at the stormtroopers, the illumination and reflections are all completely in real time. Doing this is simply impractical today. The way that you would do it, of course, is that you would fake a whole bunch of lights. That would slow down performance. It still won't look right, and all the shadows will look bandy. Second, you would create all kinds of what is called reflection probes made out of cube maps. But unfortunately, they're all moving. So every single scene, you're going to have to create a whole bunch more reflection probes, a whole bunch more cube maps. Basically, starting from the point that you would like to have the scene reflection and rendering out from that point every single direction, turning into a cube reflection map. Those tricks simply are not practical with a scene of this level of fidelity. Well, it took 4 Tesla V100s, the same GPUs that are powering the world, 5 of the world's top 7 supercomputers today. It takes 4 of them in a $68,000 deep learning supercomputer that we make called the DGX. This is what researchers use to create their deep learning AI models. And so $68,000 to finally render running the RTX platform, real-time ray tracing at about 20 some odd frames per second. Well, when we announced it, people got so excited about it.
So excited.
They said, how do we buy that DGX? We could use it as a game console. And the requests just kept coming in. How do we turn DGX into a game console? The price point is slightly out of reach for most gamers. And so today, I would like to make my first announcement. Starting immediately, DGX.
请拨打1889789，立刻订购，可以分批啊。
3,000 easy payments of $19.95. 3,000 easy payments. We'll throw in the first game for free. So call now. The telephone number is right below you. 1-889-789-2080. And good luck with that. It's beautiful, isn't it? That's just completely liquid cooled. It is silent, doesn't make a peep, and it does real-time ray tracing for the very first time for $68,000. Well, it turns out what you were looking at just now was not running on that. It was running on this little thing, this little bad guy. This is called Turing. We've been working on Turing now for almost 10 years. Trying, failing, all these different algorithms, trying, failing, and finally, Turing, the most advanced GPU we've ever done, 10 years in the making, the greatest leap since we created CUDA, and computer graphics will never be the same again. Inside Turing is 18.9 billion transistors. This GPU, this chip, is the second largest chip the world has ever made. The only other larger chip is called the V100, which powers supercomputers all over the world. It has 3 brand new processors. The SM is completely brand new, has the ability to do independent floating point and integer operations. And the reason for that is sometimes you're shading for color, sometimes you're using integer operations to calculate addresses so that you could run your shader program to do things like subsurface scattering. And as more and more special effects are to happen, the SM's address calculation part of the logic becomes much more complex. 14 teraflops and 14 integer operations per second. I like to shorten it just to 14 tips. So 14 teraflops and 14 tips. It also has the ability to do this thing I won't talk much about today, but we're going to write plenty about it, variable rate shading, so that we could do things like foveated rendering, focusing all of the horsepower to GPU where your eyes are focused instead of wasting it evenly across the entire space. If you're moving, we might be able to adapt the place where we focus your shading horsepower. If the resolution or the content detail is different across the entire scene, as most scenes are, we could focus our horsepower where there's the greatest amount of fidelity. As a result, you're effectively getting a several X boost in your shading performance instead of wasting it evenly. The second across the entire is a processor be able to adapt the place where we focus your shading horsepower. If the resolution or the content detail is different across the entire scene, as most scenes are, we could focus our horsepower where there's the greatest amount of fidelity. As a result, you're effectively getting a several X boost in your shading performance. The second is a processor we call the RT core. RT stands for ray tracing.
有字幕稍微看得懂一点了。
Gigaраys per second. I love saying that. 10 gigaраys per second. A 1080 Ti, the fastest GPU in the world today.
自动翻译没有。
1080 Ti does 1.21 G. You guys got no? Nobody ever saw that show?
自动翻译没有翻译成英文的。
gigaраys per second. Okay, and so we do 10 gigaраys per second, which is 10 times a 1080 Ti. It does ray. I'll explain that in just a second. A BVH tree traversal, and it does ray triangle intersection testing. And then we have a new processor called Tensor Core, which runs AI processing like crazy. 110 floating point teraflops. Or, because it has multiple precisions, depending on the type of networks you're running, you might be able to use lower precision or mixed precision. As a result, 440
因为它是实时生成的。
with 4-bit integer. All of this so that we could do hybrid rendering and run RTX. Well, so the question is, how does this all turn out? So if you look at the performance, it looks kind of like this. So Turing is built for RTX. And if we ran, the first thing I showed you was originally ran a GDC was DGX with 4 volts, 55 milliseconds. 55 milliseconds, about 20 frames per second. And this is what Turing looks like. 1 Turing. So 4 volts in a DGX.
DGX.
This has never happened before. This has simply never happened before. Doing computer graphics, essentially a supercomputer replaced by 1 GPU within 1 generation. Of course, it took us 10 years working in parallel. If you were to look at Pascal, this is what Pascal looks like.
帕斯卡架构。
The fastest GPU on the planet. The fastest GPU on the planet today. 1080 Ti, 308 milliseconds versus 45. Basically, about 8x. So the question is, what's happening under the hood? This is a new computing model, and so there's a new way to think about performance. It's a new computing model, so there needs to be new metrics. Back in the good old days, the vast majority of computation was done in shading. We're basically shading the color, or we're running a program in the shader, and basically we're shading. But in the future, we're going to be doing lighting, we're going to be doing all kinds of image processing, and so the pipeline is completely different. And if a pipeline is
好在
different,
今
the
天服务器
platform
给力，
software
不
has
然
got
还
to
上不
be
了
different.
4.4
The
网线。
architecture of the GPU has to be different, and you have to measure it differently.
怎
We
么
have
这
a
么
new
早开
way
学
of？ measuring. And let me talk to you about how we're going to do that. So if you look at this frame, this is abstracted, of course, but it's not too far off. Basically, within the frame that I was showing you earlier, we're doing ray tracing pretty much all the time. Okay, we're shooting rays all over the place. We're looking for intersections of triangles,
没有，我没接路
figuring
由
out
器
which。one of them has to generate shadow rays, and which one of them have to generate reflection rays, and which one of them has to generate refraction rays. And for the reflective rays, it's got to figure out how many more shadow rays it's got to generate. And so all those rays are being bouncing all over the place, and eventually we accumulate the color, the intensity, whether it's directly or from something nearby, and we shade that surface. And so we're ray tracing all the time. And that's with our RT core. That's the amount of time, the fraction of time within 22 milliseconds that an RT core is doing it. Imagine if we didn't have the RT core, multiply that by 10. If we didn't have an RT core, that green bar just simply in terms of time is just 10 times larger. So basically, all the way down the street. Shading is shading. We're doing shading incredibly well. One of the things that's really great about Turing shader is that we can now overlap or run independently floating point integer, and as a result, it's, call it 1.5 times more performant than it used to be. And then that's the integer shading there. And then for DNN processing, when everything is done, we could use it to generate pixels that we haven't finished.
没事
To generate using
我们
artificial
假
intelligence
装
the
看得
pixel
懂。
that we haven't finished. Or use artificial intelligence to generate resolution that we otherwise couldn't have. Okay? It is possible to filter information, but it's very, very difficult to generate new information that looks right. And so with artificial intelligence, we can now, for the very first time, generate missing pixels that are actually right. And we could do it in real time because we have the tensor core. And so if this is what's going on in the frame, then what's happening inside our chip? So the first part of that processing, the shader and the RT core, the Turing SM and the RT core are both concurrently running. Later on, we're shading and generating running other parts of the program. The
以后还
shader
煎显卡呢。
And so those two parts are running, the FP and the integer. And then finally, when everything is done, we're going to use artificial intelligence. All of our 110 teraflops. 110 teraflops, think of that, is basically 10 1080 Ti's. It's basically 10 1080 Ti's dedicated to doing one thing, which is artificial intelligence. And so if you just simply do the math, you have about 14 teraflops of shader math. You have 110 teraflops effectively of ray tracing.
字幕在影响你吗？其实我觉得这个字幕棒不要了。
independent teraflops and
暂时
chips,
先
and
先
then
不要字
lastly
幕好吧。
110 FP16
我
tensor
不要拿走。
core processing floating point operations per second. When you take that and do the weighted average on it, it's basically 78 tera RTX ops per second. And so the way to think about performance in the future is to figure out a way to weight all of these different types of processors. And so the way we think about Turing is 78 tera RTX
那我给你们
ops.
加字幕吧，没事。
Compare that
RTX
to a Titan X, our highest end of approximately 12. 78 versus 12. When you're running ray tracing, that's what it's going to look like, 78 versus 12. Well, one of the most important miracles, you're going to see a lot of writing about this in the future, is simply the testing. The concept is simple. You're sending an array into the scene, and you're trying to figure out which one of those
会评测
triangles
新
out of
卡。
100 million that intersects. Well, you
中
could
文不能
simply
转了，可以转我的脚
just
转
walk。 across the screen and see which one you eventually touch. Well, you got to go 100 million times. Or what you could do is you create a data structure, an acceleration data structure called a bounding volume hierarchy. Basically, it's like binning. Suppose I had 10 things I got to figure out which one is the one I
实时
want.
直播能转就
I was
见鬼了，
asked to go
哪有那么
pick
厉害？
something out. I had to go pick one of 10.
其实
Excuse
讲
me,
道理
one
可
of
以，
a
它
thousand.
它
I'm gonna
实时
put
字幕其实
10
也是在
bins
测试阶
or
段。
10 boxes, and within each one of them, I'll have 100 things. Within each box, I'll have 10 boxes with 10 things each. If I knew that, if I started looking for
If I
that
knew?
thing
哎
out of，those
现在字幕
boxes,
字
and
幕
I
比较同
discovered
步
that
了
it is in one of those larger boxes, then I can ignore every other box. And then once I find that within the larger boxes, if I find it within one of the 10 smaller boxes, I can ignore all of the other boxes. And then if I can find it within that box,
他
I
他
know it's
说
one of
还
the
在
10.
测试。
It's the same idea here. We're sending this triangle, we're sending out this ray, we're trying to figure out which one of the triangles it intersects with. And once it intersects with a bounding box, which is a large structure, which has a whole bunch of other bounding boxes within it, which other boxes within it, and within that there's a whole bunch of triangles. Once we intersect one of the bounding boxes, we know all the other bounding boxes are ignored. And then we figure out which one of the bounding boxes within, and then once we figure out which one of the bounding boxes within, we have to figure out which one of the triangles it happens to be. Well, the amount of mathematics necessary to do this is just shocking. And to do it precisely so that the image quality is perfect is really, really hard. And took us 10 years to do this.
really really hard，
Create the architecture
这
and the
很困
algorithm for
难，
doing
而
this,
且要花10
design it
年
in
的
a
时
way
间
that。actually speeds up, which is very, very hard to do because these beams, all these rays are incoherent, which is the enemy of parallelism. Somehow, we figured out a way to make all these incoherent things largely parallel, and then to create an acceleration structure, an accelerator that allows us to do this at the speed of light. And so, the RT core was invented. Well, the RT core invention had to go along with all the software layer on top of it and what we call eventually the RTX platform. At SIGGRAPH, we were really pleased to see research being done in this area. Our researchers and the researchers at the Search for Extraordinary Experience. I love that.
不说
SEED,
话，我在
Electronic Arts
我在找
research
翻译，
team. NVIDIA
我
research
在
is called
找
NVIDIA
翻译
research. EA research is called SEED. I love that. The Search for Extraordinary Experience Division. And so they worked on RTX with our
百兆光星。
researchers to figure out how it could accelerate, how it could create new computer graphics. And everything from deferred shading and direct shadows and lighting and reflections and global illumination and ambient occlusion, transparency and translucency. Translucency and transparency are just incredibly hard to do with rasterization because the concept of depth is very difficult to discern. And post-processing, as you could see, for each one of these operations, we're using different parts of the chip exactly as I described earlier. The effective ops, the effective computational capability,
是，我也好奇公版长什么样，
6 times
据说是类似于
6
煤气
times
灶那
voltage,
样子。
6-time NVIDIA V100. And so that kind of puts it in perspective. This new Turing processor, this new Turing GPU is just a monster. It's incredible. Let's take a look at some of this stuff. And so this is what it looks like. This is computer graphics today. Physically based material, direct lighting. You could see the shadows. They're hard shadows. We could try to trick it by blurring it a little bit, but it's still going to be basically that. And this is what RTX looks like. Okay, so.
我刚刚有看爆出来的公版图片，像煤气灶、双风扇。
Hey, you got to clap at the old stuff too because
空空被淹了。
it resembles us. So, here we go. I'll give you a chance, guys.
我们做了一个改变。
This is where we came from. You got to be proud of it. You got to own it. It's ugly, but you got to own it. Before, after. Before RTX, after RTX. Oh no, this is just the beginning. I'm just warming you guys up.
这只是开始。
I just gave you an olive for the appetizer. Okay, can we show him some stuff? Nacho, is it you and me?
Yes.
Okay, so this is Nacho. He's one of our dev techs, incredible computer scientist,
RTX 关闭的时
computer
候
graphics engineer.
这样子
This is what he was able to do with RTX off. RTX off. Now, of course, this scene is incredibly hard, and the reason for that is because you can't use tricks like screen space reflection here. You could put some reflection probes, but it's just incredibly hard here because things are being reflected all over the place. There's refraction. You see that graphics card back there? That's a beautiful graphics card. I announced it a week ago. That's called the Quadro RTX. And you got this crystal ball here.
现在它就
Where
是
it should reflect and refract. There's a little green ball on the ground there, and then there's that chrome ball in the back, and this empty, I don't know why, but empty glass box. And it's got area light coming in, which is really hard to do. Okay, and so in this particular case, Ignacio is doing his best to emulate the area lights, but the shadows are ugly. You know, this is the limits of today's computer graphics. Now we could fake a lot of stuff. We could fake a lot of stuff by arting it up and cause you to not look at it. But in the final analysis, this is what the limits of today's.
现在就在吹说啊，我的光线技术多么的牛逼。好，开启 RTX 模式以后，一个崭新的世界出现了。
So let's take a look at RTX on. Look what happens. The refraction of the glass globe there is just incredible. And look at this, the little caustics on the ground. The area lights cast a soft shadow. The umbra and the penumbra.
朋友们，
Notice of the
全先生
graphics
给我
card. The
给
shadow
我
of
看了一
the
个
chrome
可
ball
以
looks right. Now there's reflection of the glass box in
可以
the
在线翻译字
RTX
幕。
Quadro RTX. You see Quadro RTX from that sphere, and you see the reflection of the chrome ball with a little bit of rough surface to give you a sense of material. Everything just kind of looks right. Even the glass is casting a shadow. Even the glass is casting a shadow. Hey, let's go back to the last one again.
好像可以实时翻译有关字幕。
Yeah, I know. Now, of course, we got to add a whole bunch of paint and a whole bunch of stuff to make it look right, or we could do it this way. RTX on.
然后呢？
And there was a gasp in the audience. But this could possibly be a photograph, right?
谷歌浏览器。
Nacho, show me what you got. Oh, come on. Okay.
这就是时光线追踪。
you have to turn on a spotlight on top of that. Everything just works. Everything just works.
稍等一下。
Look, glass reflects and refracts and magnifies just like it's supposed to. And you just have to turn it on. And so the benefit of RTX is just turn it on. Thank you. Good job.
实时的光线追踪技术
And
就
so
是
now
这
I'm
么
going
的
to
牛
show you
逼。
something. We're going to turn it all
总结一下
together.
就是这
We're
样
going to put it all in. We're going to put it all together. And it's going to be a demonstration that we created recently. To highlight the power of NVIDIA RTX, this mixed mode rendering, unifying rasterization, ray tracing, compute, and artificial intelligence. And what you're about to see is
我们试一下那个实时
completely in
翻译
real
字幕
time.。Everything you're about to see is completely in real time. It's kind of hard to grok because it's going to be so beautiful, but it's completely in real time. You're going to see beautiful reflections. You're going to see inter-reflections, reflections of reflections, and it's all going to be dynamic. You're going to see beautiful lighting. You're going to see area lights. You're going to see beautiful ambient occlusion. You're going to see beautiful physically modeled materials. So things that look like metal looks like metal. Things that look like things. So beautiful ambient occlusion. You're going to see beautiful physically. That's very technical.
OK，
And that's how I talk to the engineers. Guys, we got to make things that are things look like things.
哦， 哇，太棒了！这个蹩脚的机翻，谢谢全先生，谢谢全先生提供的技术支持。不过是翻译比较纯一点。怎么有种 3D Mark 的即视感？估计是新版 3D Mark 的跑分视频。没事，机翻大家将就先看一下啊。条件有限，我并没有找到人可以来给我实时做翻译的。题是我自己搭的。这个是应该是实时光线追踪的效果。看一下我的录制没停吧，停一下，重新开始录，怕没掉。这视频之前网上有爆出来，没错。现在播放的是模仿钢铁侠，顺便致敬暴雪的西剧。有种这个 BGM 有种那个什么银河护卫队的 feel。星爵，真的很有星爵的感觉。
What do you guys think? The NVIDIA RTX running on top of a Turing GPU, hybrid rendering, real-time ray tracing for the very first time. That's the first part. Deep learning is the single most powerful computer technology.
深度学习还是最重要的强大的计算机技术。哇，这个翻译很正确。
Deep learning is a field of machine learning where using a large amount of data, you could train a supremely large neural network how to do things. You train these neural networks with all of this massive amounts of data, which is otherwise examples, on supercomputers. And this is the reason why voice recognition, natural language understanding, photo tagging, image recognition, all of these amazing feats of software are now finally possible. It is the reason why self-driving cars is even within reason to fathom. Deep learning is changing one industry after another. And people consider this the fourth industrial revolution. It is going to enable AI and computers to write software by itself, to basically run on a supercomputer, to write software by itself. At NVIDIA, we're doing all kinds of research around deep learning. We have a gigantic supercomputer that all of our researchers use to develop software. Now, some of the things that are, I'm showing you some examples here. These are some of my favorites, but there's so many. For example, you could teach a neural network how to colorize by just showing this neural network examples of, this is a black and white, this is how you colorize it, this is black and white, this is how you colorize it. It eventually learned what the pattern is, and you can give it a black and white image, and it colorizes it. You could teach a network how to take a low resolution image and make it higher resolution. Because you and I could look at this image and say to ourselves, you know what, I bet I know what pixel each one of those pixels are. And so you could use a low resolution image input and eventually get an output of a high resolution image by going the other way, which is starting with a high resolution image and give this neural network the opportunity to generate that, and whenever it's wrong, you correct it using this thing called stochastic gradient descent and back propagation. And so you literally correct it, and it tries to guess and guess and guess, and it corrects itself until one day it's able to figure out what pixels to generate. You could teach it how to take a cartoon and turn it into live video. This is a piece of work that we did in NVIDIA research.
说明天就可以预定了，可以买。
Okay, we simply taught it
真正的预
how to do
定，
that.
官网预定。
Pretty amazing, right? We could teach it to take a low-resolution CT scan and not only increase the resolution of it, but also segment it, figure out what organ is what from that blurry blue image. Okay, watch this. We taught it how to segment, how to identify which organ is what, and put a different color
非攻
around it.
吗？非攻发售要比较久，可以上色和自我纠正，机器学习。
Pretty amazing. This is going to revolutionize medical imaging.
非
We have
攻
a
没那么
platform
快
called Clara. It has the ability, you could teach it how to go find
克拉拉
identical
的
twins.
平台，克拉拉这个翻译。
Come on, you guys, that was funny. I don't. This is what we taught it to do. Change the color of the hair. All in real time. Previously, you would have to find identical twins to do that. Much harder. Now you could do it with a
现在不
artificial
用。
intelligence network. You could take a sketch and turn it into 3D. So you take this neural network, you give it a whole bunch of examples, you tell it what is the input and what is the exact expected output, and we give it a chance to try again, trillions and trillions of times on a supercomputer. Eventually, it trains and does this amazing thing. And then it creates this neural network model with hundreds of millions of parameters or hundreds of gigaflops of operation necessary to perform its task, to either classify, to predict, to draw, to generate, to imagine what color looks like. We could teach it to do these amazing things. However, there are so many architectures. It takes so much processing to do it in real time. And so we created this thing called a tensor core.
可以吧？
There are a whole bunch of them in our chip. And imagine this, okay? Imagine that a 1080 Ti is 12. 1080 Ti is what? 11 teraflops. A full 1080 Ti, a full 1080 Ti at $699 is
要改分区吗？
11 teraflops. This is 110 teraflops.
换
Basically, it
到
would
哪个
take
区来着？
10 full 1080 Ti's to keep up with the tensor core processor that's all over the Turing GPU.
要换
Now, one of the things that we taught it to
要
do
换哪
is
个区
something really？
影
incredible.
评区，影
And so we
评
taught
区，
the neural network
这个
this thing, and we're calling
影
it
影
the
评馆是吗？
NVIDIA DLSS, Deep Learning Super Sample.
那
Basically,
我
it works
那
like
我
this.
先换这个
We create a whole bunch of
Okay,
super,
fine.
super high resolution images with lots and lots of samples. So we jitter it and we create we create basically
是影评？
64 amazing images, 64 amazing images,
没
and
有
we
影
create
评吧？
hundreds of thousands of
只有影
those.
评，影评没错。
And then we
Okay.
give our network, we put a network, we put an image in here,
尽量不要断掉
and。we say, using this, it's called an autoencoder, convolutional autoencoder. It has to be temporally stable because we want to do this for live action. And so the network has to remember part of the past.
画质突然降了，
And we're going to give it a image, and we're saying, go generate this amazing image on the output. Okay? So pretty soon we'll be able to give it a new image it's never seen. We train it, and every time we train it, if it guesses wrong, we tell it what's the right answer, we propagate it back. It takes another image, it guesses it again, and if it turns out to be wrong, we propagate it back. And we sit there and we just simply loop on it on a supercomputer. We'd run it trillions of times. We run it trillions of times. And then eventually you put in an image, and it creates this beautiful image out. You create you take an image of lower resolution, say 1440p, and it creates this beautiful image that's 4K. Now, of course, the question is where did the
VPS 太给力了，哎呀，
where did that come from? Where did that magic come from? It came from partly a supercomputer. Essentially, what deep learning is doing is codifying the memories of a supercomputer, and it puts it into this neural network, basically an image generation brain. And you put this image generation brain, this neural brain, into the mathematics of our GPU. All of a sudden, it knows when it sees this image, a new image, a better version of it is that. That mathematics came about, the weights of those neurons came about because of a supercomputer. And so in the future, every game would have had the benefit of supercomputer pre-processing before you play it. And we call that platform the NVIDIA NGX. In the future, computer graphics will merge with neural net processing. We call it neural graphics acceleration. NGX. It's a framework for doing all kinds of amazing image processing. You saw earlier super resolution. We've invented super slow-mo. We're going to do all kinds of amazing things that makes video games and the images that come out of these computer graphics, CGI, look even more amazing. Basically, it works like this. We have a supercomputing infrastructure. There's a whole bunch of software that runs on it. The first thing you do is you generate ground truth. What is the perfect image? What is the perfect image? And then we have to train this model. It's a multi-dimensional manifold, and we're basically randomly walking around this manifold looking for the least error, looking for the time when you send in the image,
刚刚他说那些主要是因为他用了很多图像做了一个深度学习样本库，这项技术可以用于游戏行业。先通过超级计算机进行深度学习，再把学习的数据整合进 GPU， 从而提高游戏的运行效率。所以本质上来说，这个还是对游戏有利的，就对你们打游戏还是有帮助的。
I showed you earlier version, the desk side version with 4 GPUs. These ones have 8. And then we test and optimize it. Then you put in a low resolution image or lower quality image, or the image is in fact not even complete with ray tracing, and somehow we complete it. Somehow we make it more beautiful. The NVIDIA NGX. And then we have this AI model that we then OTA to you. You download it into your driver, into this plug-in interface called NGX, and the neural networks are changing all the time. They're getting better and better, and we put it up in the cloud, and you could decide whether you want to enhance your images or not. Then you run that on Turing. NGX driver. This is all part of the RTX platform, and you run it on the chip. Well, the supercomputer looks like this. This is the machine that is generating all of those networks. And basically, before you even run it on Turing, before you even run your game on Turing, there are a bunch of supercomputers. Here's one. There's a bunch of supercomputers.
2008年钛是9999 ，2008年是6499，不知道真的假的。人民币。
The graphics card. You guys know what a graphics card looks like, right? Here's one, available retail, $68,000. Okay? Got to keep your abs tight while you're doing this. A whole bunch of interconnects, SerDes interconnects called NVLink, connects all of these GPUs together into one virtual GPU. Every single GPU can see each other's GPU memory. All together, this board, that system has 2 of these inside. 2 of them. This is 1 petaflops. That's another petaflop, not motherboard, but mother of God, it's heavy. GPU, 2 graphics cards, makes 2 petaflops. 2 petaflops. You want 2 petaflops is basically a supercomputer with servers from that side to that side.
因为光线最终太吃性能，所以说通过机器学习的方式前叠数据库，这样子就能减少实时的运算量。
So we use this to train the neural network model. Here we go. Here. You can do it.
每个芯片的记忆是共享。
Thanks, Paul. You use that and you train this network called the NVIDIA DLSS. Okay, and then it comes up with a model like this, and this is 4K TAA. You guys know the Unreal Engine Epic's demo called Infiltrator. It's just beautiful. Incredibly taxing on systems, and 4K TAA up there. TAA is the anti-aliasing technology we invented, which is temporal. And so temporal, it takes last frame, the motion vectors, and it tries to figure out what's the best combination to create beautiful edges. Look at that, because it's temporal and the motion vectors, so many things are moving. You see a disjointed hinge over here. And this is 4K DLSS. Look at this. That's just perfect. Okay?
Okay.
Well, for the very first time, because of this, because we could take a lower resolution image, and because we could train a neural network with all kinds of super high resolution and super high quality images, this neural network, it runs on a bat out of hell processor called a tensor core, could then in real time enhance images. In real time, generate pixels it had never seen before. Generate pixels that
这边爆出来
make
了，
sense
这边
to
价
go
格都
there.
爆出来
Because
了。
if you were and I were to look at it, we would know what
2080
makes
钛
sense to go there.
999
And therefore, it makes sense that we could teach a neural network how to make sense of what pixels to put there. So I'm going to show you something.
大家都
This is
嫌它丑，
Infiltrator
确实是煤气灶。
running on 1 GPU at 78 frames per second in 4K at a quality that has never been seen before. A 1080 Ti, the fastest GPU in the world, can currently do about 30-something. Okay, from 30-something, what you're about to see is 4K. Now I'm going to lock it to 60 hertz because this display happens to be V-synced. And so you're going to see the frame rate on top, and ideally, it's pretty high. Very first time to see Infiltrator running at 60 hertz in 4K.
哇，又要看片了。这个渲染效果确实不错。是啊，你以后让苏妈每次发布会都穿裙子好了。其实不要延迟的话，就是字幕，要让字幕不延迟，可以用那个。 把那个速度调慢，把视频速度调慢。
It's just silky smooth, silky smooth. One Turing GPU, twice the performance of the highest end GPU in the world today, 1080 Ti, running at 4K with beautiful image quality. Well, you know, we should probably at this point take a look at what Turing does and RTX does for games. You guys want to see some games? Kata, what do you have for us? You need your mic on, sir.
Testing 1, 2.
Yeah.
Okay. So,
ladies and gentlemen, Keita.
All right. So first up, we have
head of our developer relations. We work so closely with developers all around the world.
他说 4K 能保证 4K 60 FPS 高画质游戏，然后说 4K 性能是1080泰2倍，当然呢是 4K 性能，4K 性能。
The work that we all do together is it just brings me so much joy, and we got this amazing developer relations teams that works with them, and dev tech team, and all these computer scientists that work with them, and man, it's just so great. I love you guys.
In my 17 years here, Jensen,
哎呀，京东真是越来越牛逼，什么东西都是他首发预定。哎，线程撕裂者2也是。
And also with the developer reception, it's been phenomenal, and we're just so pumped. It's really an honor to be here to deliver.
Keita, you know what?
Games.
I'm going to give every DevRel and every dev tech in our company a new Turing.
Oh my God! Oh. Thank you. Wow.
The number of people
京东仓库建完以后，现在开始扭亏为盈了，应该会有一些赢。仓库建完，他之前亏主要因为仓库建太多。
Is the first up. It's the latest and the really obviously. Not much needs to be said. It's a super successful franchise. Just data-wise, it sold 65 million units, and it's going to ship the Shadow of the Tomb Raider on September 14th. This time, the game has Lara Croft going on an epic adventure in Mesoamerica and South America. Just one thing to note, a parallel, Lara has a long and illustrious history, and actually, in many ways, Lara and NVIDIA has grown up together because we both
never thought of it that way.
Yeah, in the mid-90s.
Yeah.
And in fact, Jensen, it happens to be the first game I played when I bought my first Riva 128.
因为字幕是实时的，
所
以说没那么没有办法。
Grew up together.
没有延迟
So yeah, we work with Crystal Dynamics, Nixies, and IDOS Montreal, and we're excited to be able to show it.
And now what we're going to feature, we're going to show just a little part of it. Then later there's an after show. And the developers are going to talk to you about all this. You're going to be able to see all this stuff. But we're going to show you just a few things about it. So one of the things, of course, Lara Croft, you're in shadow all the time. It's all about shadows. And one of the challenges with shadows, as you know, they're just, using traditional shadows, they're too crisp. And so they have these hard shadows. And
现在它是要给大家演示光线追踪在游戏中的实际效果。谢谢白纸提供的实时文字讲解，我把它的讲解就是翻译到上面来给大家听。
And that's the first demo we're going to show you. We're going to feature ray trace shadows. Go, take it away, guys.
Hey.
Hey, Chad.
Hey, I'm over here. And apparently I work in the DevRel team with Keita, and apparently I just got a new Turing, so I'm really excited.
Bingo.
So what we did is we worked with Nixies and IDOS Montreal to bring real-time ray-traced shadows to Shadow of the Tomb Raider. It's perfect.
And so the thing to look at right now with RTX off, you saw the crisp shadows up there, and you saw right here. This is really hard to do, and that's why they don't do it at all, which is dynamic lights and shadows.
These are dynamic point lights. They're really expensive to do in current rendering techniques because basically you have to cast shadows in every direction from the light. And this goes back to what you were saying earlier about having to put a cube map here and a cube map here, and every time you move, you have to redo all that rendering. So let's put RTX to the test and have it just do it for us.
Aww. The beautiful thing about
可以
ray
看到
tracing
把
is
那
you
个
turn
动
it
态
on.
光实时光线追踪开起来后，那个影子的效果就看，可以看到这个影子实时效果。刚刚关闭的时候看不到这个效果。
Yeah,
and so the umbras where right behind where it's nice and dark, it's correct, and where penumbra where you have the softness of the shadow because not all of the shadows are occluded, part of it is lit, you get some softness.
Yeah.
你看，现在关掉了，现在开起来了。
Wow.
Now let's take you to, you were talking about some of those area lights earlier. You want to look at some examples of those?
挺明显的。
Well, here's a big example. This is an incredibly lit scene. This whole scene is amazing. It's beautiful. And so what we have here is we have 2 cone lights and 2 area lights. Those area lights are basically rectangular shapes, the neon lights above the stage. And what you notice is the shadows below are hard, like you keep talking. And this is state-of-the-art for real-time graphics right now. And I got to say, that
没有
RTX
RTX 也可以做到，但是没有办法那么的逼
This is the
真。
best we have right now.
And they look beautiful.
Yeah, they look great
until now. And the way that's simulated, those area lights are simulated essentially as a couple of point lights. And that's why you see such hard shadows.
Exactly.
But if you simulate the area lights like area lights, because we ray traced it, and independent of where the rays bounced around, eventually, if it were to hit some part of that area light, it gets lit. And so ray tracing is a much more cost-effective, in fact, however, very difficult to do, way of doing area lights.
And let's turn this on and take a look.
现在开启了
So you get the nice blend of the color and the light.
Isn't that beautiful, guys?
可以看到这个影子的效果更自然了，有没有？
It's rather.
And we can do whatever we like. We could add more area lights. We could add more spotlights. You can mix it all together without trying to fidget with it, without trying to figure out what is the definition of right. Right just looks right. That's another wisdom. Right looks right.
And talking to the artists that do this, they tell me all great things about shadows. They're telling me shadow is another color to them. They love shadow. And they also told me that shadow and light is what they use to set the mood and tone of their environments. And so that's how important shadows are. And it feels like we just gave them a lot more depth for it. Some more on, more off.
Okay. What you got?
We want to take a look at some more area lights that are very interesting.
Let's take a look at one more shadow.
All right. One more shadow. So this is kind of cool. We have the 3 area lights above, and we have hidden in kind of in shadow.
You see this? Look, I can reach that. Whoa. That right there, that's the umbra.
Okay. You want me to turn it on?
No, keep going. And that's the penumbra just now.
Okay.
Okay. You see that's the penumbra. No, keep it off. Keep it off.
Okay.
Yeah, see, that's the umbra. And notice how sharp that is. That's just not right. It should fade away. Okay, turn it on. There you go. There you go. Otherwise, it looks like another person on the ground. Look at that. The contact hardening just works.
只有高端的型号带光线追踪应该。
Contact hardening just works. The umbra works. The penumbra works. Everything just works. Okay. All right, man. Good job, Chad.
Thanks.
Guys, let's take a look at an exclusive trailer
正常玩家
of the shadow
就是
of the Tomb Raider.
普通玩家买个实系卡就够了，没有必要上新卡，我就觉得。看一下我录制有没有问题。确定一下。现在多少人在看？好奇，好奇。14000这么多。劳拉。
That's awesome. I can't wait. That's going to be a wonderful game. All right, what's up next?
Well, another blockbuster, and this time we have Metro Exodus by 4A Games.
Oh, man.
Yeah.
有啦，就是会让你的游戏中的光影效果更加真实。这个是他想体现一个东西。
In a post-apocalyptic wasteland of the former Russian Federation. You guys know this. It's been super successful. In just 2 versions of the game, they've sold 7 million units. And this one, Metro X, is due out February 22nd of next year. It's going to be well worth the wait. It's developed by 4A
你们说要
Games,
不要点个
who
餐呢？
since for the first time we met with them, Jensen, back in 2009, they're super enthusiastic and very forward-thinking. So we're not surprised that we have them here today to show.
是啊
something awesome.
，FPS 玩
Yeah,
家，
that's
所以
really
说
cool. Now, the thing
我
that
是觉得
we're gonna showcase
大部分玩家是不需要这个，就是挺多玩家不需要这个东西的。
really hard. Basically, the way light works is, can you guys see this? My light is really bright, but basically, light is coming in from the outside through those windows. And of course, this part is lit directly. And the challenge here is that's an area light, and so we have to make sure that the shadows look right. However, that light doesn't stop there. That light bounces around this room, and it illuminates different parts of the scene, depending on how close they are to that particular light. And maybe in the creases and the corners, it's really super dark, but in other places, it's more light, and direct light is completely bright. And so lighting this room using traditional computer graphics lighting is just incredibly hard. And this is the perfect showcase for global illumination. Now they want to use light, of course, to create these incredible moods. And so you feel, you know, a little scared when you walk into a room instead of being completely black, which is not right, or completely lit, which is not right either.
好像有人说京东上可以搜到预定的吗？那你们是怎么搜到的？可以发一下教程吗？或者发一下网址什么？
And so this has been something that we've been pursuing literally for a long time.
是啊，光影好就是很逼真，接近电影级的显示效果。那你觉得升级的方向应该是什么？
GI, this is GI on, and so just as I was describing earlier, the light is coming in through the window.
对 CPU 要求没有很高 ，CPU 现在性能其实是过剩的，在游戏方面。
That corner over there is
我也觉得
completely
特坦
dark,
皮好看。
and that light right above the windshield is nicely lit. It does exactly what you expect it to do.
如果是
and it does it
天
all
猫
by itself.
京东出来的话，应该就是确定的，就是没有多退少补，就是确定的价格。
Put it outside and everything just works. Everything just works. Now you could do it the other way. No, go to direct light. You see this? This is the way computer graphics basically works. Now, of course, we could create a whole bunch more fake lights. We can create a whole bunch more fake lights. But in this room, if you created more fake lights using spotlights, you'll get all these different areas that are lit too intensely and others that are not. And it looks like you basically turned on a whole bunch of lights. Now, what you could do, and what Matt did earlier, is turn on basically an artificial global illumination light, which is basically a fake ambient light. It's like somebody comes in here, and instead of allowing us to light this room with global illumination, which is happening right now from these monitors, like for example, I'm being lit by the monitor, and you guys are all being lit by this screen, this
现在还是在讲光线追踪怎么好。
And so the entire room is being lit with indirect lighting. But here, because we can't do indirect lighting back in the past, as in yesterday, we had to put a fake light in here. It's like somebody comes in here and put a fake light and constant intensity, constant color throughout this entire room. As a result, the places that should be dark, like back there, isn't dark. The places that should be more bright is the same intensity. Okay, which is what you're looking at now. So this is wrong, and let's look at right. Look at that.
毕竟是科隆游戏展嘛，多吹一吹游戏，是不是？吹完再来。笔记本要到年底了。
So Matt, our friends are now able to have like creepy monsters literally squatting in the corner.
Yeah, take a look in the rafters in the ceiling. When RTX is on, they're black. I could hide anything in there. But if I'm lighting it ambiently, you can see everything up there. When we have RTX on, it's correct. There's no light up there, so we can actually hide things in. We can make the mood and the environment perfect by just letting the normal light in the room.
Games will never be the same.
No, sir.
So scary. All right, good job. Thank you. Let's take a look at another exclusive trailer, shall we? Metro.
又是游戏宣传片，京东可以预约了，可以去群里问一下，群里应该都有链接了。我这边不关麦了。
Wow. That is incredibly scary. I don't think we have enough arrows. Okay, I'm going to flash through a couple of them, and then in the after show, we're going to show it to you. I want to save time for a whole bunch more stuff. Okay, let me show you. Assetto Corsa Competiziano.
测试一下逆水航法。
That's Italian. I spoke 2 languages today already. Okay, when you guys see it later, I want you guys to look at some stuff. Okay, first of all, the reflection on the windshield. You guys know how screen space reflection works. If it's not on the screen, there's no way to take that image and reflect it onto the surface.
我这边有在录哈，你如果看不下去，明天可以看我那个投稿录播。
Car, you see the Ferrari up there? It's reflected on top. All of the rails all the way down are reflected. No errors, no weird banding, no weird distortions. You see this guy reflected from the other side. So when you go see it, he'll be moving and everything will be dynamic. When the cars come through, you'll see all the reflections up and down this aisle of cars with other cars, the cars over the window. Everything is going to be completely dynamic and nothing had to be tweaked. Ray traced reflections and ray traced inter-reflections. Cars are going to reflect each other. If you look at the railing, the shadows are just rendered beautifully, the soft shadows, because the world is one big area light. And shadow map precisions are just not good enough to go all the way down there. And yet, for ray tracing, it just works. In fact, if you see the final game, the other way, the shadows of the last buildings are completely gone. You're going to see reflections of the toolbox of the garage and the car in the garage. Everything just works. Global illumination just works. Ambient occlusion just works. All of the soft shadows underneath the cars just work. And you can look through the window, and depending on the angle of your view, you'll see Fresnel reflection. So sometimes you see perfect reflection. Sometimes you'll see through the car. Everything just works because ray tracing just works. You're going to see another game called Atomic Heart. And this game is just really interesting. And it's got wonderful reflections and refractions. And mirrors are curved. Curved mirrors. Nobody does that. It's impossible. Not for ray tracing. It just works. You get this area light underneath, casting that soft shadow for the robot behind it. Everything is physically based. All the materials are rendered beautifully. And so area lights, reflections,
之前幽灵漏洞我有做过一次测试了，影响是 I/O 性能而已。这次我倒没有关注。
Well, guys, I want to show you something that's really cool. You guys want to see an amazing game? I can't wait for this. This is probably one of my family's favorite games.
很困的同学可以明天看我的那个投稿视频就好。
Wow, guys, I can't wait. I think we have with us Jonas and Christian from DICE. Guys.
Hello, Jensen.
Hello.
Some of the
picked up.
brightest, the most amazing computer graphics engineers in the world. We've been working together on implementing RTX into Battlefield 5. Now, you guys, the anticipation of Battlefield 5 is so great. I don't think I
怎么
need
说
to
呢？我觉得
introduce what is the
提升是
concept
在
of
4K
Battlefield
性能
5.
和
It is a World War
和
II
那个
FPS.
画质
It
上
is
和
part
画
history,
面表现上，
part travel, part time travel, part running for your life, part destruction, real-time destruction.
提
You've
呗
never seen
提呗。
destruction like there is destruction. Isn't that right,
性
guys?
能我现在也
You
不知道，
guys know
我没有测过。
destruction.
你
You
不要
guys
问
know
我
how to
说
blow
性
it
能怎么
up.
样怎么样？
Okay? This
玩玩。
there's mayhem, there's chaos. You work as a
4K 性
team,
能
you
是
can battle by yourself.
1080
I want to go learn all
2倍
kinds of stuff about World War II by going through your game. I just want to be a tourist. Turn on God mode and go through as a tourist. So we're going to show you some pretty amazing stuff. Isn't that right, guys?
That's
All
right.
Let's
是游
Okay,
戏
Jonas,
卡
let's go. Take
是
it
游
away.
戏卡。
Yep, Christian.
All right. Thank you, Jensen. Thank NVIDIA for hosting such a great show. This is really cool. I'm Christian. I'm a tech director for Engine Group at DICE. And next to me, we have Jonas, media and video editor. We're here to show you our implementation, our vision, our take on what RTX can be. And we want
怎
to
么
show
突然
that
给到这么一
in
个
our
画面？
brand new Battlefield 5. And in the setting, we'll take a look at our brand new multiplayer map, Rotterdam. And it's a really dense and cool city map. We'll start here in a very zoomed-in view of the soldier's eye. And we're going to observe something that we've never really been able to do before. So we at DICE have worked closely with NVIDIA engineers over the past year to get to the point where we are now. And we're so proud and thrilled to be here and show it off to all of you. So, Jonas, I'll leave it to you. Take it away.
Yeah. So, what you're seeing there is a tank firing off screen, being reflected in the character's eye.
Now, you guys know this is not possible
No.
with screen space reflection, right, Jonas?
Exactly. This is
Because the fire is not on the screen.
So now if we turn around and we then see the environment, we can see that the tank muzzle flash not only reflects in the eye, it reflects in the entire environment in the tram windows there and within the
我微
tank
信在
itself,
想，不好意思。
moving here. So now if we keep moving forward, yeah. That's great. So of course, one of the big challenges of SSR is also complex surfaces like this. So now with RTX on, if we set off an explosion behind the tank here, but next to the car,
Oh,
we'll
come
see it
on.
reflecting accurately within the car.
That's impossible.
Of course,
How would you do that with RTX off?
yeah, how does that look? Like this here.
哦，这
So
个
let's,
这个
yeah.
对比
Wow,
就
that
很
looks
明显。
incredible.
And it's, of course, it's
Wow, 这个-
updating dynamically
这个
everything.
效果
Reflections will never be the same
确实可以。
again.
Completely
Look at the
fine.
reflections off the ground, guys. It just
Yeah, so you can see
wow, it just happens.
with SSR, if it's in the screen space, you still get some of the reflections upon the car, but due to the nature of SSR, it disappears as it goes away. But because ray tracing just works, you just get the expected result, how you think you would see it. So the next thing we have to show you is the big, scary crocodile tank, the Churchill. And if we make that one shoot, its flamethrower across the scene here, then we will again see that reflecting upon the surface and on the soldiers battling it out here in Rotterdam. So now if we look down in the ground with RTX on, we'll see the flame, we'll see the soldiers moving, we'll see everything. And now if I turn RTX off, we lose everything. We lose all the detail, all the context of what's happening in the scene. But with RTX on, you just get a much more cohesive image and a better understanding of what's happening around you. So one thing we also pay particularly much attention to in battlefields is just the weapons, accuracy, making sure the smallest detail is correct. You can see even there, the flames are reflecting properly in the wood of this gun here, and in the windows in the back. Now if I turn RTX off again, you lose all these details.
逼真啊！
So,
总结一下就
really
是
cool
Now,
thing.
Jonas, what you guys have done is all of your guns, all of the objects are modeled physically.
肯定是可以
It's
做到这
physically
么
based. And so the gun has wood, which is diffused, is a dielectric material. You have metal, which is reflective, and the metal has substructure in it, microstructure in it, so there's some roughness in it. And so without doing anything at all, because it's physically based, we shoot a ray into that scene. It intersects with a triangle on that piece of metal on the site, and it figures out, I need to boink, generate another reflection ray, and it traces its way to the flame, which is coming by, and when it comes by, it accumulates on that surface, it shades it perfectly all by itself. Ladies and gentlemen, the magic of ray tracing.
Exactly. And there's more. So, what you see now are objects that are really close by, but ray tracing works for more yet. So up here we've got two C-47 airplanes. They've been shot down. They're crashing with their engines on fire. So now if we go over to the car here, you can see the flame reflecting in the car nicely over there.
秋霜烈日
Moving forward,
他来给我们做一个
and
实
then
时的
look
讲
down
解。对，
on this
给大
reflected car right
家打个
here,
招呼吧。
you'll still be able to see
这
the
里
plane.
有点尴尬，有点尴尬，这个真的。
没事没事，
You
不会
can
不
see
会
the
没事
plane
没事。
reflecting in the car.
来，
If I move this lens.
Okay,
Wow,
okay.
your lens flare works
Right there.
good.
And then with RTX off,
I love
it's
it.
everything up.
Yeah, look at that.
Keep moving forward.
Wow.
So
没事没事。
And Jonas, you guys did a great job with for now reflection. Look when the angle is just right. It's just a perfect mirror. It looks
我们声音
So
调
here
小
is
一
a
点。
good
现在
example
主要
of
是在
surfaces with
讲
vanilla
RTX
NVIDIA rendering.
的，
The
主要
more
是
an
在
angle
讲
you're at, the
RTX 光
stronger
线
the
追踪。
reflection gets.
So
And now with what
就
we
是
have
主要就是说
before,
希望这种多牛逼动能。其实说的话，光线追踪其实追踪在不是在很早之前，在好几年之前就应该。
And of course, as I said, the old school cube maps, they are also static. So say that we were to destroy this building here, make a tank shoot it, with ray tracing on, you will be able to see frostbites and Battlefield's destruction system within the window, moving dynamically. And now,
嘿，
to
你
end
那
it
边
all
就是
off,
在没有说话的时候，麦先低调。对，
OK，
然后要说话的时候把麦开起来就
we
可以。
were to shoot off a V1 rocket here and zoom out, get a good view of the entire street of Rotterdam, and then take a look at the windows, all the places that you would expect to reflect. For now, turn up the time again, and we just wait patiently for the V1 to hit the ground. And there.
That's awesome.
That's great.
Good job, you guys. Good job. That's really great. And
Thanks
it's
a lot.
amazing what you guys did so fast. I know you guys worked super hard, but it's amazing how you guys implemented this stuff so fast. I mean, that's one of the benefits of ray tracing. You know, the benefits of ray tracing is because things are going to behave physically.
就是之前我得到的消息是说，到9月中旬才能拿到，就是才会发售什么的。那现在不知道为什么今天突然动了预定了，我不知道这个预定指的是现在能预定，然后9月份来发货还是怎么样？我觉得应该没有那么快发货。
When you guys create a scene, things would just look right and behave accordingly. And so this is really just such a great achievement. Wow, things are still falling apart. I've never given a talk in total destruction before. You guys do destruction great. You're great at destruction. That's a lot of pent-up anger there, sir. Lots of great destruction. Okay, you guys made an amazing trailer. Let's take a look at it.
要换游戏了吗？哦，并不是，实时的效果。 现在有是有，但是是一个不知道是预约，就是预约归预约嘛，发货什么时候不清楚。积分还是要开的很，就是大家还是挺多人看不懂的，积分还是可以作为一定的参考的。没事，我们还有秋霜烈日大神给我们讲解。
You guys killed it! Real-time ray tracing.
你们
Battlefield
杀了他。
And we have a great surprise for you today. Battlefield 5.
会有很多游戏适配这个 RTX 线。太惊讶了！老黄的意思就是这个技术把我自己都吓得半死那种感觉。
可以。
Developers all over the world are working hard on RTXing.
就是这些是支持 RTX 的游戏列表，是吧
？We're going to have all kinds of amazing games coming your way. Well, I guess your question is this.
哎呀，碧水寒肯定是不会支持。
RTX 就是大的还是那个 AI 感觉。
Well, let's show it to you.
逆水寒？哎，真有逆水寒吗？真的假的
？60赫兹输出，采用 DP144 standard。
又是一个选手片。
2080，我的2080，我的妈！哇！
回来开玩笑的，真的是2080，
真的是2080，别吧？
图都出来了，图都出来了。
啊
？8K HDR 60赫兹。
是。
哇，这个要煤气灶。哇，这个还有背板，真的是煤气灶。我刚刚不是发个动态，新版煤气灶。哎，出来了，终于出来了。
是我们做过的最好的设计，
千呼万唤始出来。
我们重新改良了散热系统。
The GeForce RTX 20 Series。
而且这会让它运行的更加安静，而且散热会更加高效。
The craftsmanship is unbelievable. The craftsmanship is unbelievable. This is the best design we have ever done. Everything from the voltage, the power regulation, and the thermal management system, it is designed for overclocking. Crazy amounts of overclocking. Not to mention, it is just so quiet. Even when you're maximum overclocked. At maximum overclock, it sounds like 1/5 the audio levels as a 1080 Ti. It is so quiet. The engineering is
是说它静音效果很好。
We're announcing 3 models today. We're announcing 3 models today.
2070，哇，今天把2070也放出来了。
The RTX 2070 with 6 gigaраys per second, 5 times that of a Titan X. 5 times that of a Titan XP. 45 trillion RTX ops per second.
是没有泰坦皮好看的，说实话，没有泰坦皮好看。
45 trillion RTX ops per second. That is several times the performance of a Titan X. 8 gigabyte frame buffer. RTX 2080, 8 gigaраys per second, 60 trillion RTX ops, about 6 times the performance of a Titan X for ray tracing, 8 gigabytes, and then the RTX 2080 Ti, 10 gigaраys. I love gigaраys.
声音调大指的是
shoot as many rays as you like. Go crazy, just shoot rays.
今天就可以开始。
RTX ops
已经可以预定，官网可以预定。
starting at $499.
499.
Starting at $499. Pre-orders today.
今天就可以订。
On shelf everywhere, September 20th.
9月20铺货。
核弹套装啊！
And here is your NVIDIA RTX family. The NVIDIA RTX family. The NVIDIA RTX family. The NVIDIA RTX family. Ladies and gentlemen, soon I'm going to see the NVIDIA RTX family.
价格。
The NVIDIA RTX family. Quadro 8000. Quadro RTX 8000. 2 GPUs connected by NVLink, turning it into one large virtual GPUs. 96 gigabyte frame buffer. 166 trillion RTX operations. 166. 166. That is basically 16 Titan X's in one PC. $20,000. $20,000. Now just imagine, that is twice the ray tracing performance of a $68,000 DGX station. Twice the performance of a $68,000 supercomputer. Then you have the GeForce RTX family. The 2080 Ti from $999. The 2080 from $699, and the 2070 from $499, and the 2070 is higher performance than the $1,200 Titan XP.
Look
at it this way. I want you to look at it this way.
我的 VPS 不行了。我们先换个720P 的国度一下。什么情况？哎呀，我的404网站
卡了吗？这是
卡了。
这问题不起来。
我刷一下。
还有老黄的官网是不需要翻墙。
官网不用翻，应该是我的 VPS 出问题，但是官网就没有。
你试一下用我的，我把我的。
OK，
rasterization and ray tracing, compute using and artificial intelligence. Artificial intelligence that was trained using supercomputers, and all of those neurons and all of those weights from all of that experience then sits inside your PC, and it generates images that no possible software written by humans could do. And it generates beautiful images. The Turing, the largest generational leap in the history of our company. The most important new GPU we've created in 10 years since CUDA. 78 tera RTX ops. 78 trillion ops. Basically, changing things so dramatically, we have to change the way that we talk about performance. Because in the future, you're going to ray trace parts of the image, you're going to rasterize parts of the image, you're going to use post-processing on some of the image, and you're going to use artificial intelligence to generate all kinds of pixels that are impossible to generate otherwise. And the GeForce 20, the GeForce RTX 20 series, starting at $499.
重新基本上是全部重新改进架构啊、算法啊，还有一些包括设计上的很多东西。
$14.9是什么东西？哎呀，又卡了。
Okay, I have one more surprise for you. The guys did something. Well, everything is real time. It's physically based. All the materials are modeled properly. Reflections just work. Inner reflections just work. The lighting just works. Ambient occlusion just works. Area lights just works. Have I told you that before? Lighting, reflections, shadows, it just works. Everything could be dynamic. No cooking necessary. No art necessary. Just turn on the lights. Enormous amount of computer graphics capability then kicks in and draws the rest of it. Everything you see here is all completely in real time. Ladies and gentlemen, have a great Gamescom. It's been a pleasure being with you. This is a historic moment. Computer graphics has been reinvented. Thank you very much.
那个预定网址有个同学说发在我们的动态中。性能对比提升的话，不同方面不好说。反正现在大家也都没测过，你也没法下定论，是不是？我记得传言是说提升没有很大，就是只是说加入了光线追踪这样子。2倍是在4K 性能上。
讲道理，光线追踪也不是新技术了吧？
也不是新技术，就是实时光线追踪，用在 GPU 上，游戏卡的 GPU 上还是第一次吧，就是实时光线追踪，它不是实时光线追踪，结束了，结束。这歌词都我翻译的，可以。这个居然没有，请观众朋友们一步现场体验区体验一下我们的新型。官方说2倍，您要看在什么游戏下2倍是吧？如果是比如说优化过游戏支持实时光线和追踪的话，那么提升肯定是蛮明显的。是吧？
不，官方那边就结束。
官方那边直接卡掉了是吧 ？OK， 行，那我们差不多吧，今天就到这里了吧？是吧，看一下，没其他的。那感谢秋霜烈日的这个解说。
播了一会儿也还行。
我们把这首歌听完就下播，行吗？这首歌还不错，很有听觉的感觉。我超喜欢银河护卫队。
还有我的妈！
还有什么？
还有那个现场体验什么的结束。
没了。MV 这边是没的。OK， 行，好，那我们直播就到这里啦。OK， OK， 大家晚安，早一点睡。然后如果没有看完的，明天看我发的。
Hey everybody, Shannon Morse back here at the NVIDIA 2018 event here in Cologne, Germany, and it has been amazing so far. We got to see the incredible keynote done by the CEO and all the trailers for all the different video games look incredible. I can't wait to play them myself. I know we're going to get some demos hands-on here at the event, so I'm sure that everybody that you can see behind me right now are definitely as hyped as I am. But I am absolutely excited to see these new GPUs in hand, get some demos on with those video games with the new 2080s. I don't know about you guys, but I am so incredibly excited about this. We definitely have a lot going forward that you can be looking forward to as well on the stream. So if you have any questions, definitely put them down in the comments. We'll be throwing over to those questions as much as possible so that you can get all those tech answers in case you want to know anything in particular. And of course, you definitely need to check out the brand new Battlefield 5 trailer, which just came out. I'm super excited about that. Let's go ahead and check it out.
超兴奋的。再录一会儿，再录一会儿。截个头尾，视频也好看一点，是不是？
Wow. That I had to scoop my jaw up off the floor after that.
I could watch that like 100 more times and still be completely fine with it.
So we obviously just saw the Battlefield 5 trailer again showing off RTX, which as you can see now, we're on brand already. We've got the RTX logo.
Oh, I didn't actually see the logo until just now.
Take a look, everyone. Ooh, yeah, grab that. So, thoughts?
Well, I've had a chance to actually play Battlefield 5 a little bit. But I didn't get to see it like that, right? And I've seen this trailer now like 3 times because I got to watch it on big screen. But they just showed it to you guys again, and I got to watch it on a little laptop so I could kind of refresh it. But I don't think I've ever seen so many reflections in my life. I was like, I don't know if I need the fire to be reflecting on the water, but then I saw it.